Hello to the world of YouTube. Hello, people of the world. It's Paul Whittakin back with my periodic table of mathematics numbers. And I'm going to try and stick to the math part today. Some might say I get carried away. One of the things that I am a proponent of is that mathematics has relationships in not only natural sciences but to all of the subjects in life, and you can make correlations. You know, I remember studying calculus or whatever, and you know, we learn about derivatives and integrals, and they show that you can take the slope of the line as they do in algebra. And in reality, that's just the derivative, and the area underneath the curve is the integral of that. And it's all very, very intelligent, and it was a great discovery for sure. And I thank, Mr. Leibniz and Mr. Newton for those discoveries and accomplishments. They did a lot for us. But one thing I would like to try and kind of point out first of all is, I think I have something here that might help to demonstrate this a little bit, and that is just, this is the Fourier series, and Monsieur Fourier came up with this thing, and there's also Riemann's theorem and Parseval's theorem and all these things, and they're great. But somehow when I look at this, I just remember back in the days when I was at the university and they gave us, all this material to prepare for all of these exams, and all I would get is just a knot in the gut, and it all made me kind of want to puke. And the methodologies that they used in the university, it wasn't so much all about teaching us, it was kind of like turning us into zombies. I observed the people around me literally turning into one-tracked mind zombies. And, what happened was they went on to work for the government making bombs and weapon systems, pharmaceutical companies where they made all kinds of pharmaceutical concoctions, biochemistry industry, and now we're genetically modifying food and plants and the like. And there's something to reflect upon all of that, because it's not always for the advancement of the human race. It's kind of, it's been distorted a little bit. But anyway, what I have here is the universal law of numbers, and it's my contention that this law of numbers is literally, it's like the primordial soup of all mathematics and science. It is the seeds and the roots from which the tree grows and branches out into all branches of mathematics and all branches of science. And that's a pretty big claim to make, and I do understand that. But I don't really take credit for any of it, because it's just something that I discovered. It's probably been something that's been discovered and rediscovered and discovered and rediscovered throughout history, and that's my contention there as well. Now, one thing I would like to kind of build up first is, this thing about these branches of mathematics. So we have trigonometry, and we're starting to use these sines and cosines and all of that, and that sort of is what leads to this, and it's a beautiful thing, and I like cosines and secants and cotangents and tangents, and I get it for the most part. But I would just have to say it's just the 369 code. It's this. It's this. It's the Fourier series. It's this, But this is something that anybody can understand. Anybody can get an appreciation for, starting from preschoolers. Really, they can, because with these matrices that I've shown, they're beautiful things just for kids to use as a coloring, to color in the numbers, whatever. They will gain a great appreciation through osmosis of the relationship of numbers. So if I did this table and I did it like, 3 and 3 is 9, yes. 4 and 4 is 16. 5 and times 5 is 25. 6 times 6 is 36. And it would go on forever, and it wouldn't even be apparent necessarily what the relationship of these numbers are. So that's the beauty of the reducing the numbers. And reducing numbers I'm reducing your numbers, people. I'm reducing the same numbers. By reducing the numbers, you see the patterns, you see the symmetry, you begin to understand the simplicity, and that's a beautiful thing when you go on to pursue, some career in mathematics, natural sciences, music, art, architecture, engineering, anything, just the basic, the study of life, because this is where life comes from. And I give it names. Today's name, eternity, infinity, creation. Okay, that's the name. Where was it born? It was born out of the black hole Big Bang. Okay, when was it born? 0, 0, 0, 0, 0, 0. It will never die. If you want to give it a number, it's not a social security number. It's 248751369. And it's not a joking matter. Now, within the code are individual codes. And these lines going across are all codes in themselves as well. And these lines, if you add them across, they're going to either come up with a 51, a 54. Well, they all come up with either a 51, a 54, or a 33. This one right here comes up with a 33. So what I'm going to do is I'm going to tie something in, and, mathematicians might not like me for this. And I'm not making any claims. I'm just using my own intuition. So what we have are these, what we refer to as irrational numbers. Now, Fibonacci number, I don't know if that's considered irrational or not, but I've clearly demonstrated that it is a repeating sequence. I've also clearly demonstrated that, pi and 2 pi, the circle, are embedded in my code. We all know, or many of us know, that phi and the Fibonacci numbers are related. By dividing the Fibonacci numbers, it gets closer and closer to phi. But it's my contention that all of these numbers are related, and in a sense, they're related underneath the umbrella of the universal law of numbers. Now, we call these irrational numbers, and I do understand the concept, but I don't like the terminology so much because, first of all, these numbers are my friends. I don't think there's anything irrational about them at all. I believe people can be irrational and people can have difficulty understanding them. And one of my main goals is to make this world of numbers more understandable. And thank you, the universe, for the code, because that's basically what it does. It brings all of that complicated this back into something that any average person can understand. So what I'm going to do is I'm going to basically say, now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now those are numbers, and those are the only numbers. They're the only numbers we have. Every number is a combination of one of those numbers. And we also have this thing called 0, which, it's undefined really. A number or not a number. It creates a little bit of a problem in the number system because, first of all, if I go 2 plus 3 is 5 plus 3 is 8, plus 3 is 11, which is 2 again. You know, that sequence continues. What happens if I start going beyond 0 and go that way? Well, we have to start all over from 1 again, and then the whole thing works. It's sort of like the square root of minus 1, we call it. It's a dilemma. And the same thing happens here, because if I go, 2 minus 3, that would be 1, 0, 1, minus 1, minus 2. And that's not going to where it's supposed to at all. But anyway, that may be besides the point. But there are a couple of things in mathematics we don't really understand that well. They're sort of perplexing. 0 over 0, 1 over 0, 0 over 1, 0 to infinity, infinity to the 0 power. All of these things are a little bit confusing. But anyway, back to my point. Now, I have Euler's number here, Bernoulli's number, some call it, pi, phi, the square root of 2, the Fibonacci sequence, and my numbers. Now, this is just the first 9 numbers of my code, which is a code of 54 numbers, starting with these 9 right here. So once again, to point out, we have them adding up to 51, 54, 51, 54, 33, and 54, I guess. In any case, there are 3, 6, 9 numbers, and that's for sure. So all of these numbers, these very famous numbers, we have, if we take the first 9 of each of these numbers and we add them up, including 1 through 9, they always give us a 396 number. So Euler's number adds up to 39, pi adds up to 36, phi adds up to 39, square root of 2 adds up to 27, Fibonacci's number adds up to 54, because I say, well, whatever, don't worry about it, I won't go there. The first sequence of my numbers add up to 51. But we know that the other sequences that I just pointed out, they add up to 54 or 33. So I will just point something out. Euler's number 39 plus 51 is going to be a 90. Well, that may not be a coincidence. Pi is 36. Phi is 39. So anyway, with pi, if I take one of my other sequences of numbers, one going across, it would be 54. 36 and 54 are going to be 90. Now, phi, 39 and 51 adds up to 90. With the square root of 2, 27, and this line right here adds up to 33. That would make it a 60. 54, that's Fibonacci's number. I've already demonstrated that Fibonacci's number is related to this number right here behind the universal law of numbers. And all I'm doing is making observations. Somehow this number is related to all of those numbers, and it's sort of like the father of those numbers as well as the father of all numbers. That's my contention. So you may study this yourselves, and maybe some of you are much smarter than me, but none of you are going to be smarter than this. I'm absolutely sure about that. Now, when it comes to geometry, we have all of these different polygons, etc. I'll name some of them. Well, we have triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, and in this one here, basically they're just calling by the number of sides of the polygon, up to 100 sides. But in each case, the sum of the interior angles is always going to add up to a 9 number. Okay, now that's not a coincidence because geometry is a 369 mathematical code, and just glancing at all of the different polygons, etc., you will see the three. Basically, you'll see mostly nines, but you'll see threes and sixes and nines. You know, when it comes to a triangle, we might have an equilateral triangle with 60, 60, 60. Well, 60, 60, 60 is 180. 60, that's a 6, and it's 3 times 6 to come to 180. It's all 3, 6, and 9, and I'm pointing out something that's not new to any of us at all. You know, that's something that we all completely understand. Now, what I'm going to do today is I'm going to do a little bit of my arithmetic and, you know, some of my counting. And counting is arithmetic, but counting is also the art of mathematics, because all mathematics is counting, all counting is arithmetic, arithmetic is subtraction, division, addition, and multiplication, and all branches of mathematics are based upon that. So what I'm going to do is, first of all, I want to repeat this one because I kind of screwed this one up one time and I want to do it better. What this line is going to tell us, it's going to tell us how odd numbers, it's going to explain us the concept of odd numbers, and it's going to also explain to us the concept of even numbers. So what I do is, this is subtraction, if you like. It's just a way to look at numbers, and it's a way we should look at numbers. 9 to 1 is 1 because 9 plus 1 is 10, which is a 1. The difference between this one, 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 and this one. 3, 5, 7, 9. The difference between 7 and 7 is 9 because 7 plus 9 is 16, which is a 7. So we have 3, 5, 7, 9, 2, 4, 6, 8. Okay? That's all I wanted to do with that one. Now, there are many ways to, you know, chop this thing up. But one way you can chop it up is by threes along these lines on the top. So what we get here is 1, 4, which is a 5, 7, 7, which is a 5, and 4, 1, which is a 5. 7, 7 is a 5 because it's 14, which is 1 and 4 is 5. We can always ignore the 9s. This line here is 9, 9, 9. Okay? This line here is 8, 8, 8. This line here is 6, 9, 3. This line here is 2, 2, 2. And this line here is 3, 9, 6. So what we have there is the 369 code with, I'll show you, 5, 8, 2. So the 582 is the 369 code as well as the 174 or 714, 147. That's also the 369 code. 285, 714, 417, 818. 818 is basically 72, but it's the 369 code as well, because 1 and 8 is 9, 1 and 8 is 9, 1 and 8 is 9. And even the ones are the 369 code, because if we chop them up like 2 of them, 2 of them, 2 of them, you get 2, 4, 6. I did that 3 times. I divided this thing by 3. 3 and 6 is 9. It's all a revolving circle around 3, 6, and 9. I say, you know, 285 or 528 is the 248751 code. But the 248751 code is also the 369 code, because 3, 6, and 9 are the only numbers that you don't have there. And they come in the proper places too. So it becomes much easier to get this grasp of this thing we call mathematics. It's simpler to understand, and I think the more you understand this that I'm trying to communicate right now, the easier it will be for you to study and to advance to all levels of mathematics. Because this is the seed and the roots, from where the roots come from, of the tree, the branches out into the entire tree of mathematics. Okay, so we're going to kind of, excuse me for that, I'll try not to do that again. That's bad, my bad. What can I say? I'm kind of clumsy. And also I goof up numbers sometimes, but it's only me. It's not the Almighty, okay? It's just me. I'm not perfect. Okay, what we're going to do is we're going to try and start looking at the differences between some of these numbers. So when I look at the numbers, I look in between them. Between these two, between 1 and 4, and I'm going to go down. 3, 7, 6, 4, 9, 1. 3, 7, 6, 4, 9, 1. I see the 3, 6, 9 there, and I see the 7, 4, 1. So I see the 7, 4, 1, 7, 1, 4. I see the 3, 6, 9. What happens if I go between this one? I get 5, 1, 2, 4, 8, 7. 5, 1, 2, 4, 8, 7. That looks familiar. 5, 1, 2, 4, 8, 7. Or 2, 4, 8, 7, 5, 1. That's the way I like to say it. What if I go between 1 and 9? So it's going to be 8, 8, 8, 8, 8, 8, 8, 8, and 8, 8, 8, 8, 8, 8. Well, 8 is also an important number, and 8 we find, for instance, in chemistry you talk about, or they talk about octets. In music we talk about octaves. You know, 8 is also a series. As a series, it's also a very important concept to understand in mathematics and science. What happens if we go between 1 and 7? Okay, this between the first line and this one. Okay, we're going to get 6, 9, 3, 6, 9, 3. Well, that sounds familiar. 3, 9, 6, 6, 9, 3. I can go for that. What about between the 4 and the 7? Okay, we have 3, 2, 6, 2, 9, 2. 3, 2, 6, 2, 9, 2. Well, I see 2s there, and I see the 3, 6, 9 code. And 2, 2, 2. Well, 2, 2, 2. What about 2, 2, 2? Well, it's a 6. We got 2, 2, 2 over here too, right? 2, 2, 2. I like 2. I don't know what more to say about it right now at this particular moment. Let's go from 4 to 9. Or, well, we'll just do it right here. Maybe I did it already. It doesn't matter. Do a 5, 1, 2, 4, 8, 7. 5, 1, 2, 4, 8, 7. 5, 1, 2. Yep, we did that one already. Okay, what about from the 7 to the 1? Okay. 3, 7, 6, 8, 9, 4. 3, 7, 6, 8, 9, 4. Well, I see the 3, 6, and 9, and the 7, 1, and the 4. That's what that one is again. What about this right here? Between 1 and 9. Well, we did that one. What about between, what's another one to do? Okay, here's somewhat a mirror image of these two are somewhat mirror images of themselves. I'll do it quickly again. 3, 7, 6, 4, 9, 1. Here we have 3, 7, 3, 4, 9, 1. So the only difference was the 3 and the 6, I guess. So in any case, it's giving us a lot of symmetry. And I guess that's the point, because in my mind, it's not all about memorizing equations. It's more about just plainly recognizing the patterns and the symmetry, and that's what mathematics really is. And I want people to realize that, because I want to reintroduce these friends of mine the apostles of the Almighty, 1, 2, 3, 4, 5, 6, 7, 8, 9, they're our friends. And they've been mistreated. And they've been mistreated because they're used against you. They're used against all of us. People who understand numbers are able to manipulate us in many ways through the power of numbers with bad intent and bad results and, usury, for instance. Now, if I were to try and put usury into this system, it would change all of the numbers, it would distort them, and then we would lose sight of the beauty of nature and the beauty of the universe. And I have to tell you that, usury and mind control are the two techniques of deception that are used to control us and turn us into subjects, whatever, clones. They're used to basically brainwash us and dumb us down. What can I say? It's just that's my position, and I don't like it because I don't think that's the way. I don't think we should live under some monarchy of usury. I think we're going in the wrong direction of that. You may or may not understand, agree, or what, but I think there are some people out in the world who really don't want me to be saying that or elaborating on it for sure. But anyway, world, Paul Whittekin here. I'm wishing everyone in the world peace and happiness. We have natural disasters going on everywhere. I think it's something we might take note of. I don't call it global warming. I don't call it climate change. I don't know if it's the sun doing it. I don't know if it's HAARP doing it or weather manipulation. But for one thing is for sure, we should really stop polluting our environment. And we should stop polluting our information as well. Everybody yelling at each other, getting red in the face over all of these things. But if we just follow like a simple code, I think it will guide us to wisdom and unity. And that's what I hope I'm doing. So until next time, this is Paul Whittekin, and I'm checking out. Bye.